Have you ever wondered how a decimal that repeats forever can be written as an exact fraction? In mathematics, repeating decimal may seem infinite, but they actually follow a clear and predictable pattern. By using the concept of geometric series, this infinite decimal can be represented systematically and converted into fraction. In this video, we will explain the relationship between repeating decimal and geometric series and demonstrate how this method allows us to obtain precise fractional values.
So first, I will talk about what a geometric series is. A geometric series is basically a sum where each term is formed by multiplying the previous term by the same number, which we call the common ratio. In general, it looks like a plus ar squared plus ar cubed and so on. Now, repeating decimals can actually be written in this form. For example, 0.6666 can be written as 0.6 plus 0.06 plus 0.006 and so on. So here, the first term is 0.6 and each term is multiplied by 0.1. Since this is an infinite geometric series and the ratio is less than 1, we can use the formula s equal to a over 1 minus r. Substituting the values, we get s equal to 0.6 over 0.9, which simplify into 2 over 3. So this is how a repeating decimal can be converted into a fraction using a geometric series.
Next, a geometric series only converges when the epsilon r is less than 1. Epsilon r is less than 1, the terms getting smaller just like this and approach toward a fixed value. But if the epsilon r is bigger or equals to 1, the terms grows larger, just like this, and the series diverges to infinity. For a convergent series, the sequence of partial sum s1, s2, s3 to sn approach to a finite limit L. We write as this formula. That means that L isn't just what about the sum approach, it's exactly the sum of the infinite series.
So I'm going to show you how to convert repeating decimals into a fraction. Let's say we have 0.4444 with infinitely repeating number of decimals. We can change it into 0.4 plus 0.04 plus 0.004 plus 0.0004 and so on. So the first thing we need to do is to identify the first term A, which is 0.4. And the second thing we need to do is to find the common ratio R. To do this, we need to divide the second term with the first term, or the third term with the second term. So we will get 0.1. So as we know, if r is less than 1, it is converged. So there are two methods that we can use to change repeating decimals into a fraction. So the first thing is using the summation formula. So the formula is this one. So we just need to plug in the numbers, but in here we need to change the limit from n is approaching infinity, because we have infinitely numbers of repeating decimals, and then we just plug in the numbers. We get 4 over 9, which is equal to 0.44444. And then the second one is using the infinity summation formula, which is a over 1 minus r. So we just plug in the formula, and then we get 0.4444 and so on.
Real world application. Suppose you roll a fair 6-sided die. What is the probability of getting 1 or 2? You may try it yourself first before reveal the answer. Probability is the number of variable outcome divided by the total outcome. So in order to get 1 or 2, our number of variable outcome is 2, and our total outcome is 6. And then we simplify these fractions into 1 over 3, and then we convert it to the decimal, which is 0.333. This decimal repeats forever, so it's a repeating decimal. Now instead of stopping here, let us understand why this decimal repeats and how it is exactly equal to 1 over 3. To do that, we can write this expression. So from this expression, we can see it forms an infinity series. Now let me ask you, is this series a geometric series or arithmetic series? Yes, it is a geometric series because each term is formed by multiplying by the constant ratio but not adding by the constant difference. Hence, we can use the sum to infinity formula that we mentioned earlier in this video. You may pause the video and try it yourself first. So this is our first term, which is our A. And how can we find our ratio? Our ratio can be calculated by taking the second term divided by the first term. Note that our R is less than 1, so the series is converged. So the method 1 is explained if you use the geometric series. So if you use the geometric series, you have to know that r power n, when the n is approaching infinity, you will get 0. So the final answer, you will get 1 over 3. So how about if you use the sum to infinity formula? Actually, you will get the same answer as the method 1. Hence, this is a geometric series that converges to 1 over 3. The probability never becomes exactly 0.333. It's converged to a fixed value, which is 1 over 3. So writing it as a fraction will give you the exact probability.